We were basically trying to find a model that describe how nuclei and electrons inside an atom are interacting with each other, how they move with respect to each other. First model that was developed to describe the atomic structure was just thinking of the atom as a miniaturized solar system. So it's just a small solar system with the massive nucleus in the middle, like the sun, and the electrons are moving around it in orbits like the planets. However, this is a very classical description for the system, and that will pose a lot of problems with classical laws of physics. For example, if they are just simply moving around each other, what prevents electrons from slowing down and losing energy, then spiral and collide with the nucleus, which means the atom should just collapse? Or what prevents it from gaining energy and just escaping the attraction of the nucleus? There is nothing in the classical physics that would prevent the electron from doing either of these phenomena. And apparently this doesn't happen, because if it happened, the atom will basically collapse, which means we will not have any substance or anything in the universe around us. But it just proves that this simple idea of the composition of the atom is not correct. How we were able to develop an alternative description of the atom was based, as I said, on the interaction between atoms of different substances and the light. If the classical idea of the atom, according to Rutherford, was correct, the atom should have been able to absorb or emit all types of frequencies or all colors of light. So all substances around us should have been absorbing all types of frequencies or all colors, or emitting all types of frequencies or all colors, depending on how close or how far the electron moves from the nucleus, which apparently is not what we actually observe. In a discharge tube experiment for any element, where you take a vapor of the element in the tube and use high voltage to kind of excite the sample inside the tube, is gonna start emitting light. And when you analyze this light, is gonna be a line spectrum with specific colors rather than a continuous spectrum with all colors. So the electron inside the atom is actually emitting or absorbing very specific colors with specific frequencies in what is called a line spectrum. And this here is the line spectrum measured for hydrogen atom. And actually, the line spectrum is a common phenomena for all elements. If you excite any sample of any other element, it's gonna emit a line spectrum of its own. It's gonna be a different line spectrum, but it's a line spectrum, not a continuous spectrum. So that idea here is suggesting that the electron is not moving at any distance from the nucleus. It's actually moving in certain specified distances, or what we call orbits, from the nucleus at certain distances. And what happens is that it's allowed to only jump from one orbit to the other and not in between. So basically, like when you drop a ball over stairs, the ball can be stable on top of one stair or the other, not in between. So the ball will be moving in jumps between the steps. So it's either stable on step 3, step 2, or step 1, not in between step 1 and 2. So that's exactly what happens for the electron. It's either stable at the orbit of what we call the ground state, the minimum energy orbit, or the one closest to the nucleus, or stable at the next orbit or the next orbit. So it's basically gonna be jumping between these orbits. If it got enough energy that equals the difference between the two orbits, is gonna jump from this orbit to that one. That's why you will see specific lines that correspond to the jump from orbit 1 to orbit 2. That is going to give you the red line, for example, and the jump of the electron from orbit 1 to orbit 3 is going to give you the green line, for example. So that's why you have specific lines, not a continuous spectrum of all colors.